Hello everyone, we are Team KiloByte and our selected problem statement is Smart Traffic and Parking Management System for Solapur Municipal Corporation. I am Sashun. Let us look at the problem first. So Solapur being approved for the smart city faces traffic congestion problems due to heavy vehicle movement, illegal parking and roadside encroachments and narrow road infrastructure, which reduce usable road space and block smooth traffic flow. So what we propose is a solution that uses cameras and sensors placed at junctions and busy roads to continuously monitor traffic, parking behavior, and roadside obstruction. That is a zone-based vision intelligence system using AI cameras and sensors. Uh, so when the traffic starts building up, the system automatically adjusts traffic signal timings to allow smoother vehicle flow. If illegal parking or roadside encroachment is detected, these locations are marked as problem areas and alerts are directly sent to the concerned authorities. An all information dashboard, centralized monitoring dashboard, allowing authorities to see parking violation, congestion points, and encroachment affected roads at a glance. So, with the help of this system, it helps to improve the overall traffic experience for the citizens of Solapur.
Explains the technical architecture of our smart traffic and parking management system. We start with the city zoning and baseline mapping, where Solapur is divided into dynamic mobility zones. Key junctions, parking areas, and congestion prone routes are identified, and baseline traffic data is collected. Next, we capture real-time data using AI-enabled CCTV cameras and IoT-based parking sensors. These sensors detect vehicle count, traffic density, illegal parking, and parking slots which are available. The edge devices processes this data locally to reduce latency and network load. In the zone intelligence layer, AI models analyze congestion patterns and dynamically adjust traffic signal timing. The system also predicts short term traffic flow and parking demand using historical and live data. All processed data is streamed through MQTT to the backend infrastructure where it is stored and managed securely. Finally, a centralized dashboard provides the real time monitoring, congestion alerts, heat maps, and decision support tool, enabling authorities to take fast and data driven action.
All right, my name is Khushi and I'll be explaining about the subsystems. Now, there are total six subsystems in our problem statement. The first subsystem is the traffic monitoring module, where the live data feed is being captured from the CCTV footage and the vehicle movements are being detected to identify the congestion levels and the traffic density in multiple areas. The second is the adaptive signal control, where the traffic signal timings would be adjusted based on the real-time congestion data that is being received. The third one is a parking management module where we detect the parking occupancy, identify all sorts of illegal parking that is being there and provide the availability status of parking in the nearby areas. Now, the fourth one is the encroachment and obstruction monitor. It would detect the hawkers, illegal blocked lanes, and also the roadside encroachment that are there through the centralized monitoring system. Next one is a central processing and analytics engine. Now it would process all the incoming data feed from the CCTV live footage, computes the congestion levels where there are much traffic and less traffic zones, and then it generate alerts according to that data feed received. And the last subsystem is a central monitoring dashboard, which would display the live traffic status, the parking data, what are the alerts that are being sent on live basis, and also the system control options for both of the management of the traffic smoothly. Architecture is being divided into four major layers. The first one is the user layer, where we have a complete traffic police dashboard for the management of the traffic in the areas, where one person can easily monitor the dashboard through parking areas, through traffic zones, signal timings, and everything can be easily monitored. The second would be a user-friendly citizens app where the user can easily track their movements, and the emergency services API that are there. The second layer would be a presentation and processing layer where we have the real-time data feed that are being received through the live CCTV footages, and then identifying the traffic red zones and green zones where high alert traffics are there in multiple areas or not. And then you have a complete optimization engine that manages all this processing layer smoothly. Next would be the edge layer, where we have the IoT sensors and the vision based module, which would easily detect the vehicles in red zone areas, and we can have a complete dashboard analytics where we can identify the traffic signal zones and manage the red lights accordingly. The last layer would be the actuator layer, where we would control the commands and we can easily adjust the timings where we do not waste any sort of resources and sensors and can control the traffic density at peak times.
Let's talk about why our solution is not just innovative but truly deployable. Technically, we built on a proven AI and IoT ecosystem using a modular edge prescribed architecture. This means cities like Solapur can integrate a system with existing traffic infrastructure without expensive replacements while still scaling in the future. From an operational standpoint, We keep humans in control. Authorities get real time insights, manual override options, and a gradual automation pathway, making adoption practical, not disruptive. We also proactively addresses risks, anonymized data processing protects privacy, network fallback ensures reliability, and a pilot first rollout minimizes implementation challenges while building stakeholder trust. In short, our solution is feasible, scalable, and ready for real world smart city development. Not just a concept, but a practical step towards smarter mobility.
In this slide, I will explain the impact and benefits of our smart traffic management system. First, for citizen, our system reduces congestion uncertainty and provides predictable parking availability and improve the road safety and helps people plan their travel better and save time. For traffic police and authorities, the system reduces manual monitoring burden by providing real-time data. It supports data-driven decision-making, enable proactive congestion management, and ensures transparent enforcement. For hawkers and vendors, we clearly identify how impact zone, which reduces conflict with authorities and gives better predictability in their daily operation. For emergency services, the system enables faster corridor creation, signal priority routing, and reduces response delay, which can ultimately save lives. Finally, for the city and environment, it ensures smoother traffic flow, reduce idle emissions, improve urban livability, and supports smart city readiness. Overall, our solution creates benefit for citizens, authorities, vendors, emergency services, and the entire urban ecosystem.